Hello everyone. So this is lecture number 2 on probability distributions. We are going to understand discrete random variable or discrete probability distributions in a greater detail over here. So let me give the topic name as discrete random variable or discrete probability distribution. Now you might be wondering what is a probability distribution. Now probability distribution is nothing but if we conduct one experiment, so all possible events in that particular experiment and all possible and their respective probabilities, all possible events and their respective probabilities. Now for example, we when we toss a coin, so the sample space becomes t comma h, okay, a single coin. So if x is a random variable which denotes the number of heads, so x will take up the values 0 and 1. X will take up values 0 and 1. Now why it will take 0, the value 0 is because when we toss a single coin, there can be 0 number of heads, okay, or there can be one head, okay. There cannot be two heads because there is a single coin, okay. So these are all possible events and their respective probabilities. Respective probabilities will just calculate, okay. So 0 heads, so there is only one event out of two events in the sample space, okay, and one head, so there is only one event out of two events in the sample space. Now these are all possible events. X is nothing but a possible events, okay, and p of x is nothing but probability of those respective events, right? So this is nothing but probability distribution. Know what is a probability distribution? So this is a probability distribution of the number of heads as an example. Now see, try and understand, the sum of all probabilities is always equal to 1 in a probability distribution, okay. So that becomes the one of the criteria for discrete probability distribution. So probability distribution is following a random variable follows probability discrete probability distribution. The first criteria we can say is that sum of all probabilities, summation of all probabilities is equal to 1. And the second criteria is individual probabilities. Now look at this. These are individual probabilities. Individual probabilities should be greater than or equal to 0. There shouldn't be any negative probability. See, event can be negative, but then probability cannot be negative, okay. So this two criteria are very important, basically, that summation of all probabilities is equal to 1, okay, and individual probabilities for all probabilities and individual probabilities should be greater than or equal to 0, okay. So with this understanding, we will take some problems from the government textbook, right? So let us go to exercise 8.1 of our government textbook, right? In exercise 8.1, question number 1, which is on page number 140, 140. Fine. X, let X represent the number of heads and number of tails obtained when a coin is tossed 6 times. The difference between, sorry, I did not read that word. Difference between the number of heads and number of tails when a coin is tossed 6 times. What are the possible values of X? Okay. If you want, you can read the problem one more time, okay, at your end. What are they asking in this problem? What are the possible values of X? Right? A coin is tossed 6 times. So the first value of X, okay, the first value of X, first of all, we'll write what is X. X is the difference between number of heads and number of tails when a coin is tossed 6 times, right? So we have to mention this. Then we'll prepare a table. X, number of heads, number of tails, okay, and the difference. and difference is x. Okay. So out of 6 times, there can be 0 heads. And if it is 0 heads, then 6 times we'll get a tails. So the difference is -6. Are you able to understand this? 6 times we are tossing a coin. 0 times we are getting heads. So naturally 6 times we'll get tails. So the difference is 0 minus 6, which is -6. Now out of 6 times, n is equal to 6, right? Out of 6 times, if one time we are getting a head, then 5 times we'll get a tail, right? So the difference is 1 minus 5, that is equal to -2. Likewise, 2 heads, then out of 6 times, if there are 2 heads, then we'll get 4 tails, right? So difference is -2 over here. 3 heads, then 3 tails, difference is 0. 2 heads and 4 tails, sorry, 4 heads and 2 tails this time. So the difference is 2. 5 heads and 1 tail, the difference is 4. And 6 heads and 0 tails. So out of 6 times, if there are 6 heads, naturally there will be 0 tails. So the difference is 6. So this is what they were asking. So you have to give the represent, or frame it up in this manner. Yeah. So this was the first problem. Let us go to the second problem. Fine. An urn, it is same on page number 140. An urn contains 5 red and 2 black balls. 2 balls are drawn at random. X denotes the number of black balls drawn. So X is nothing but number of black balls. So we just have to find out the possible values of X. Okay. So 2 balls are drawn at random. Okay. 2 balls are drawn at random. We have to find out the values of X. So X can be 0 black balls out of the two. 2 balls are drawn at random, and both the balls will be of red color. Okay. Then the second value of X will be 1. Okay, 1 black ball. So it can be red and black, or black and red. So it can be 1 black ball. Okay. And X can also be 2 black balls. See, because we are drawing only two balls. Okay. Okay. So 2 balls are drawn. What is the possibility that both are black? They're not asking us the probability, but then they're asking just like what X will represent basically. So both balls are black. So the case will be both are black. So X can take up all these values. They are not asking the probability, but then they are simply asking what X can represent. Okay. Yeah. Then let us go to the next problem. Just a second. Page number 140. Question number 3. Okay. Determine whether each of the following is a probability distribution. We have to find out whether each of the following is a probability distribution or not. Okay. So the first thing is, for a probability distribution, these two criteria should be fulfilled. Sum of all probabilities should be equal to 1, and individual probability should be greater than or equal to 0. Okay. So question number exercise 8.1, question number 1, question number sub question 3, I mean. Okay. So it's on page number 140. It's question number 3, exercise 8.1. Fine. So sub question 1, they have given the table. I'll just write down the table for you. P of x is equal to 0.4, 0.4, 0.2. So this is given to us. Now check each and every individual property. Each and every individual property. So we'll write down all properties. This inverted A is called as for all, right? All probabilities are greater than or equal to 0. Okay? All probabilities are greater than or equal to 0. Right? Then we'll also calculate the sum of all probabilities. So 0.4, 0.4, 0.1, 0.2, which is equal to 1. So both the criteria are fulfilled. Both the criteria are fulfilled. So this is a probability distribution. Therefore, it's a discrete, or even if you don't mention discrete, it's okay. It's a probability distribution. Now, probability distribution can also be called as probability distribution function or probability mass function. Okay, probability distribution function or probability mass function. Okay, yeah. Second sub question. Second sub question. I'll write down the problems for you. The table, I'll just copy it for you. 0.1, 0.5, 0.2, minus 0.1 and 0.3. Now try and observe over here. One probability is negative over there, right? So we'll just mention P of x equal to 3. X equal to 3. The value of this probability is equal to minus 0.1, which is less than 0. So the first criteria is not getting satisfied. Therefore, not a probability distribution. We can simply write that thing, not a probability distribution. We don't have to check the second criteria because, as I said, you both the criteria should be true. Okay. Right. So there is one more problem after this. The fourth sub question. Third, you can solve it on your own. They have given in terms of z, so don't get confused what is z. Z is also a random variable. Random variable can be given any name, x, y, z, anything, right? And probability of z. So 0.3, 0.2, 0.4, 0.05, again 0.05. Okay, this table is given to you, right? So we need to find out whether this is having a probability, it's a proper probability distribution or not. Now individual probabilities are all positive. There is no negative sign, so that's fine. We'll write all possible probabilities P of z are greater than or equal to 0. So the first criteria is fulfilled. Second criteria, P of z, summation of P of z. That means addition of all this. So when you add all these probabilities, what is the total that you get? You can just calculate for yourself. See and tell me the answer. The total is 1. So summation of probability of z is equal to 1. So both the criteria are fulfilled. Therefore, it's a probability distribution. Are you able to understand? Right? And remember one thing, these z values can be positive or negative. That's fine. This is okay. Okay, but then probability of z should never be negative. Otherwise, it is not a probability distribution. Fine. So I think in this question there are many sub questions. You can try many of them on your own. Okay. So next thing, exercise 8.1, question number 4. Okay. What they have given? Find the probability distribution of number of heads in 2 tosses of a coin, number of tails in 3 tosses of a coin, and number of heads in 4 tosses of a coin. So first part, X is what? Number of heads in 2 tosses of a coin, right? So for 2 tosses of a coin, I'll just write down the sample space. TTHH, TH, TH. This is for 2 tosses, the first toss and the second toss. So there are 4 total events, right? And they are just asking the probability distribution of 2 tosses of heads in a 2 tosses of a coin. So X can take up 3 values. X can be 0, 1 or 2. See, we are tossing the coin 2 times. So out of 2 times, there can be 0 heads, there can be 1 head, or there can be 3 heads, 2 heads, sorry. Okay. P of X. P of X. That is the probability of each and every event we need to calculate. And hence we'll get the probability distribution basically. Right? So 0 heads. 0 heads, I'll color it with blue. So this event is 0 head. And this is only one event. Out of how many events? Out of 4 different events. So 1 out of 4, right? One head. One head, I'll just color it with red. Okay. So 2 events out of 4. And 2 heads. I'll color it with yellow. So 1 event out of 4. So this is what is required. This table was asked and we have prepared one table for them. First sub question, I should say. Now second sub question. In the second sub question, what are they asking? Number of tails in a 3 tosses of a coin. Now whenever there are three tosses of a coin, first of all I'll write down what is X. X is number of tails in 3 tosses of a coin. 3 tosses of a coin. Okay, so sample space for 3 coins. If a coin is tossed 3 times, or if a coin is tossed 3 times, or we are throwing 3 different coins, the sample space will remain the same. So it is TT, 4 times T, 4 times H, then TTHH, TTHH, TH, 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 TH. Okay. So X can be 0, 1, 2, 3. See, we are tossing the coin 3 times. So out of 3 times, the number of tails can be 0 number of tails. Not a single time will get a tail. One time will get a tail. 2 times will get a tail. And all 3 times will get a tail. Okay. So probability distribution of X. Okay. 0 times we are getting a tail. So this red colored event is that event in which we are not getting a tail even once. So this is 1 out of 8 events. Now one time we are getting a tail, yellow color, one time tail, one time tail, one time tail. Then 2 times tails, 2 times tails, 2 times tails, and 2 times tails. Okay, so oh sorry, I just made a mistake over here. The yellow color occurred 3 times. The green color is also 3 times. That is 2 times tail. And the last one, 3 times tail, which is marked in blue color. That is just for your understanding. So it is one event out of 8 events. So this is what is asked in the second part of the problem. Okay, number of tails in 3 tosses of a coin, right? Yeah. Then third part of the problem. Now in the third part, what are they asking? Number of heads in 4 tosses of a coin. In 4 tosses of a coin. Now here the sample space is very big, I should say. So I'll just give you an example of this. For four tosses, or if a coin is tossed 4 times, or 4 different coins are tossed, the sample space will be like this: 8 times t, then 8 times h. I'll just make it vertical for you. 8 times t, 8 times h. Okay. Then 2 times t, sorry, 4 times t, 4 times h, 4 times t, 4 times h. Then 2 times t, 2 times h. Then 1 time t, 1 time h. This is the sample space for 4 tosses of a coin. So these are 16 events. Each row is an event, right? So these are 16 events. Now here x is what? 4 times we are tossing the coin. Okay, and they are asking the probability distribution of number of heads. Number of heads in 4 tosses of a coin. So x can take up what all values? X can take up 0, 1, 2, 3, 4. Okay. X can take up what all values? 0 times it can be heads, 1 time heads, 2 times heads, 3 times heads, 4 times heads. P of x. P of x 0 times heads. I'll just mark it in blue for you. So this is 1 out of 16. Okay. Likewise, 4 times heads. This is also one event out of total 16 events. So 1 out of 16. Then 1 time head, only one head. Okay, so I'll just mark it up for you. Only one head. Only one head we require. Fine. So these are 4 events out of 16. Okay. Then 2 heads. Two heads. 1, 2, 3, 4, 5, and 6. Okay. 6 out of 16. Then 3 heads. I'll just put a tick mark. 3 heads, 3 heads, 3 heads, 3 heads. 4 out of 16. So this is the probability distribution. I have written it vertically as I don't have space over here. You can copy this horizontally for yourself, right? So this completes the problem. This was question number 4. Okay, right? We'll proceed with exercise 8.1, question number 8. Okay, yeah. In this particular question, it's on page number 141, 141. The random variable has probability distribution. So they are very clear in their communication that we are having a probability distribution over here. So we are supposed to find out the value of k. So since we have a probability distribution, right? Therefore, summation of p of x is equal to 1. We don't have to prove it. They have given it is a probability distribution. So k plus 2k. I'm adding up all the probabilities over here, plus 2k once again, plus 3k, plus k square, plus 2k square, plus 7k square, plus k is equal to 1, right? Now see, so we'll get 10k square, 10k square plus, add up all the k's, 9k is equal to 1. I added all the k's, okay? The red colored are k's. So I'll solve this on the next page. Therefore, 10k square plus 9k minus 1 is equal to 0. Factorize this. The factors are 10 and 1, 10k square, sorry. This is 10k square. So 10k square plus 10k minus 1k minus 1 is equal to 0. 10k, k plus 1. I'm taking 10k common from both. Minus 1, k plus 1 is equal to 0. 10k minus 1, k plus 1 is equal to 0. So this gives me 10k minus 1 is equal to 0. 10k is equal to 1. Therefore, k is equal to 1 by 10. Okay, and one more case, k plus 1 is equal to 0. Therefore, k is equal to minus 1. But then k cannot be minus 1 because all the probabilities will be negative then. So this case is invalid. So our final answer for the first sub question is k is equal to 1 by 10. Okay. Now few more things are asked in this particular problem. Okay, let us just go through it one by one. They are asking p of x less than or equal, less than 3, right? Just remember k is equal to 1 by 10. Okay, k is equal to 1 by 10. Just remember that. Now I'll just draw this table for you. 1 2 3 4 5 6 7. P of x, k, 2k, 2k, 3k, k square, 2k square, 7k square plus k, right? So they're asking p of x less than 3. So look at the values of x which are less than 3. So it is 1 and 2. See, 3 we don't have to consider because it is not less than or equal to, it is only less than, right? So don't consider 3. So p of x less than 3 is equal to k and 2k. So k plus 2k, which is 3k. Put the value of k as 1 by 10. So answer is 3 by 10. If you are able to divide it, well and good. If it's a very difficult division, leave it in fraction, reduced fraction, right? So this is p of x less than 3. Second part they are asking is p of x greater than 4. P of x greater than 4 will be 5, 6 and 7 because these values are greater than 4. So add their probabilities, k square plus 2k square plus 7k square plus k. Okay, so this will be 10k square plus k, and put the value of k as 1 by 10. Fine. So this will be 10 into 1 by 100 plus 1 by 10. 0 0 will get cancelled. 1 by 10 plus 1 by 10, this will be 2 by 10. Fine. Okay. Yeah. So let us go to the miscellaneous exercise and solve some problems from there. Go to part one of your miscellaneous exercise. Part one of your miscellaneous exercise. Okay. It's on page number 155. Yeah. Part one, question number one. Sorry, question number two. Part one, question number two, which is on page number 155. Right. So this is the problem related to K. Okay. So all probabilities should be equal to one, and then you can take this problem for self study. Question number uh, two. I'll take up question number three from page number 155. That is page number 155, question number three. Right. Okay. So let us understand few things over here. X is given, P of X is given. X is equal to -3, -2, -1. One second. -1, 0, 1, 2, 3. P of X 0.05, 0.1, 0.15, 0.20, which I'm writing as 0.2. 20 and 2 is one and the same thing after the decimal point. 0.25, 0.15 and 1. 0.1, sorry. Okay. Now they are asking find the probability that X is positive. X is positive. So what are the positive numbers over here? 1, 2, and 3. So add their respective probabilities. So this will be 0.25, 0.15, 0.1. We should add their respective probabilities. Okay. Yeah, we'll get the answer. And guys, 0 is not a positive number. Okay. Neither positive nor negative. Second part of the problem, they're asking X is non-negative. That means negative sign should not be there. So this time 0 does not have a negative sign, 1 does not have a negative sign, 2 does not have a negative sign, 3 does not have a negative sign. Okay. So we'll add all these probabilities. Right? Have you understood this to get the answer? Then X is odd. They are asking when X is odd. So odd numbers over here are -3, -1, 1, and 3. So add all these probabilities 0.05, 0.15, 0.25, and 0.1. All these probabilities, if you can add, you'll get the answer. Next thing they are asking is when X is even. X is even. Okay. They are asking X is even. So even numbers are -2, 0, and 2. Add their respective probabilities. So where I'm marking an arrow, you should add those probabilities. I hope you have understood this question. Okay. Yeah. Right. Now let us take one problem which will make us understand what is a CDF, cumulative distribution function or cumulative density function. That is a CDF. And it is denoted by capital F of X. It is denoted by capital F of X. Okay. So same page 155, page number 155. Okay. Part one, question number 5. Page 155 of your government textbook. question number 1, sub question 5. So I'll be solving this right now. Okay. So x is given as 1, 2, 3, 4, 5. P of x is 1 by 20, 3 by 20, a 2a, 1 by 20. Okay. Now since we have a probability distribution, it's given in the problem that we are having a probability distribution. So summation of p of x is equal to 1, since we have a probability distribution. Like write full forms in your exam. So 1 by 20 plus 3 by 20 plus a plus 2a plus 1 by 20 is equal to 1. So all the properties we have added and it is equated to 1. Now don't reduce this 1 by 20 and all, because we'll keep a common denominator 20 in the denominator. Okay. So 1 by 20 plus 3 by 20 plus 1 by 20 will give me 5 by 20. 5 by 20 plus 3a. So 5 by 20 plus 3a is equal to 1. So 3a is equal to 1 minus 5 by 20. 20 minus 5, that is 15 by 20. So cross multiply 15 by 20 into 1 by 3. 3 gets cross multiplied. 3 ones are 3 5s are. So a is equal to 5 by 20. We got the value of a. Okay. Now if you read the problem, they are also asking you what is CDF, right? So first of all, we'll complete the table by putting the values of a. A value is 1 by 20, 5 by 20, sorry. Why we are not reducing it? Because we are keeping a common denominator over everywhere, a uniform denominator, that is 20, right? So p of x 1 by 20, 3 by 20. Now a is 5 by 20. We already have calculated this. 2a. So 2 into 5 by 20. This will be 10 by 20. And the last value is 1 by 20 once again. Okay. So this is your PDF. Now CDF. Okay. Capital F of x is the CDF. Keep the first value as it is. Okay. 1 by 20. Now add 1 by 20 to 3 by 20. So it will be 4 by 20. Add 4 by 20 to 5 by 20. So it will be 9 by 20. Add 9 by 20 to 10 by 20. So it will be 19 by 20. Okay. And add 19 by 20 to 1 by 20. So it will be 20 by 20. And the last value should always give you 1. Last value in the CDF row or CDF column should always give you 1. So basically this is how CDF is calculated. Okay. Right. Let's take one more problem of the CDF category. Just a second. Same page number 155. Question number 8 you can do. Question number 8 entirely you can do for your self study. Okay. I think the same problem we have done in the exercise. It's a same problem from the exercise. Okay. Main exercise, that is 8.1. Now from page number 155, we'll go ahead with question number 9. Again, this problem is important because in this problem we'll have to calculate PDF first, because see, CDF is given. Try and understand. CDF is given. We'll have to calculate the PDF. Okay. They're asking, see, find the probability distribution of x. So reverse way. X minus 3, minus 2, minus 1, 0, 1, 2, 3, and 4. These values are given to you. But then they are given in the form of CDF. So 0.3, 0.1, 0.3, 0.5, 0.65, 0.75, 0.85, 0.9, and 1. Okay. So P of x, we'll calculate P of x. The first value will be as it is, 0.1. Now the second value will be calculated in this manner, 0.3 minus 0.1, that is 0.2, 0.5 minus 0.3, 0.2, 0.5 minus 0.65 minus 0.5, that is 0.15, 0.75 minus 0.65, that is 0.10, 0.85 minus 0.75, again 0.10, 0.9 minus 0.85, so that is 0.05. Don't commit any silly mistakes. And 1 minus 0.9. 1 minus 0.9 is 0.1. So this is P of x, right? So we have learned two things: how to calculate CDF from PDF, and in this problem we have learned how to calculate PDF from CDF, right? Yeah. Then one more thing they are asking in this problem, that is probability of x lying between -1 and 2. And -1 and 2, these values are inclusive. -1 and 2, these values are inclusive. There is a equal to sign over here. So what all probabilities you'll have to calculate? So -1, it will start from -1, 0, 1, and 2, right? See, the interval is given over here, -1 to 2. So we'll have to add up 0.2, 0.15, 0.10, again 0.10 to get the final answer, right? Okay. So let me search for some more problems which can be done in today's class. Okay. So I'm searching in the objectives part. Miscellaneous exercise objectives. Page number 153. MCQs, choose the correct alternative. Second question. Now this is a bit conceptual. Okay. X is given as -2, -1, 0, 1, 2. P of x is also given. Pi is nothing but P of x. 0.3, sorry, 0.2, 0.3, 0.15, 0.25, and 0.1. So this is P of x. They are asking f of -3. Okay. Now see, F, capital F indicates CDF. Now -3 is not there over here. In this probability distribution, -3 is not there, so the answer will be 0. Okay. One additional thing I'm teaching you over here. If they're asking you f of 3, again 3 is not there over here, but then 3 is on the right hand side after 2, 3 occurs. Okay. And the final answer of capital F of x is always 1. So the answer of 3 will be taken as 1. It's cumulative distribution function. So before -2, if any number is there within the CDF part, the answer will be 0. And after 2, whatever number is there within the bracket, the answer will be 1. I hope you are trying to understand the technique over here. Okay, fine. Then few more things I'm just looking out for. Fill in the blanks. Fill in the blanks. I think it's on page number 154. Fill in the blank number 3. Okay. They're asking summation of p of x for a discrete random variable. It has to be equal to 1. It has to be equal to 1. Okay. Now, few more conceptual problems. Fourth fill in the blank. Fourth fill in the blank. See, x is equal to 0, 1, 2, 3. And p of x, they have given you a formula, x minus 1 upon 3. So you can calculate the individual values by the formula. So the first one will be 0 minus 1 upon 3. Second one will be 1 minus 1 upon 3. I am putting this value of x over here individually in each calculation. 2 minus 1 upon 3. 3 minus 1 upon 3. Okay. Fine. I think they have framed this problem in a wrong manner because the first probability, this one is negative. Okay. They should have not given this f of 0. 0 should not have been given. But any which ways, we'll try to answer whatever they're asking. Okay. They're asking f of 4. Now try to recollect. F is CDF. And in CDF, I have said you, after 3, after the last value, whatever value comes, the answer will be 1. Okay. Additional part, if they're asking you f of minus 2, so before 0 whatever value comes for CDF, it should be 0, right? Yeah. So this was a conceptual one, but then the problem was not framed in a right manner, as I said you, because the first probability occurs to be 0, to be negative. Question number 5. X is equal to 0, 1, 2, 3, 4. P of x, again some formula is given. I'll not explain this formula right now. That will be covered up in the next class, but then let us understand what are they asking. They're asking capital F of minus 1. Now minus 1 is before the first entry. X is equal to minus 1 is before the first entry. So answer for this is 0. The CDF answer will be 0. Okay. One additional thing, if they're asking you f of 5, so 5 occurs after 4, so answer will be 1. If they're asking you values which are before the first entry, the answer will be 0. If they are asking you values which are after the last entry, the answer will be 1. And these are all CDF values. CDF. Okay. Go to true or false, which is on page number 154. Okay. First true or false. X will take up 0, 1, 2, 3, 4 values. P of x is given. Right? They have said ki f of 5 is equal to 1 by 4. 5 occurs after 4. 5 occurs after 4. Okay. So f of I should ideally be equal to 1, but they have given 1 by 4, which is false, right? Second true or false. X is equal to minus 2, minus 1, 0, 1 and 2. P of x values are given to you. Okay. And they have given f of minus 3 is equal to 0. Now minus 3 occurs before minus 2. So answer has to be 0. So hence it is true, right? Fine. So this was the first lecture on discrete probability distribution. Okay, so we'll take up one more class. There are total 3 lectures on discrete probability distribution. So the first one is completed. The second one will be taken care of in the next lecture, and there is one more lecture based on discrete probability distribution, which is for mean and variance of a discrete probability distribution. Thank you, guys.